talking this much. But first, second, third term, and we're gonna keep following this pattern. So, like I said earlier, there's a total of there's 8 terms. So if 8 is n, then there's n plus 1 terms. So there's a total of 9 terms. So I'm gonna do this pattern 9 times, and that's how when you get the whole formula. I mean, that's where you get the whole expanded form of the whole thing. So let's do a harder one. Just so let me find an empty page, just so we can better understand what just happened. Like, what did I just do? Because I feel like I haven't explained it well. So, okay, here's an empty page. Okay. Let's do actual harder one. Okay, so let's do x, or actually, yeah, 3x plus 7y. Let's do that to the power of, I don't know. Let's do an even power because we got 2 odd numbers. It doesn't really matter anyway. Let's do to the power of, I don't want to do to the power of 10 because that would be too easy. Let's do to the power of 6, okay? So basically, from what I've shown you earlier, the first term has to be 1. It's 1. And then 3x multiplied by 3x to the power of 6. And that's the first term. We're going to be plus. And it's going to be, it's going to be 6. Because here's 6. That's going to be a second term. Multiplied by, multiplied by 3x to the power of 6 minus 1, which is 5, and then 7y to the power of 1. Okay? And the third term is where we start using the formula, which is 3 minus 1. So 3, remember, it's always, sorry, it's not this, sorry. Ignore what I said earlier, it's this. So it's always this exponent. Okay, 6 minus 1 equals 5, okay? It's always this minus 1, that's the next term. This minus 5, and now you have to multiply 1/2 to it. So 5 times 1/2 is 2 1/2. And now you gotta multiply 2 1/2 to the previous coefficient. So it's 2 1/2 multiplied by 6. So that 2 times 6 is 12. 12 times, so it's 2 and 1. Oh, sorry. So there's 12, so it's 15. So this one, so it's 15, okay? And then 3x to the power of 4, and then 7y to the power of 2, okay? So that's this one. Now, that's the third term. The fourth term, we're going to do all the way, let's just finish the whole problem. That's what I'm planning to do, because there's a lot of terms. Now, the fourth term is going to be where we're going to be dealing with the 1/3. So this one is, we're going to do, we just did 6 minus 1. Now we're going to do 6 minus 2, okay, which is 4. We're going to multiply 4 to, we're going to multiply 4 to 1/3, which equals to 1 1/3. Okay, 1 1/3 multiplied to the previous coefficient, which is 15. Okay, so with 1 1/3 multiplied by 15, it gives us 20. So this one is going to be 20, and it's going to be 3x to the power of 4 minus 1, which is 3, 2y to the power of 3. Okay? And all you guys have to do really is just simplify these to get the... I'm going to simplify it for you guys later to show you guys how it actually works. But it's really, really easy. And plus, let's continue. Wait, we don't need to continue because guess what? We know that the first half, okay? So the first half, okay, it repeats in the second half. We know that from the Pascal's triangle. So let me show you guys the Pascal's triangle. But basically, it repeats, so it's really, really... So in the Pascal's triangle, you can see 1, 1, 3, 3, 1, 1, 4, 4, 6, 1, 1, 5, 5, 10, 10, 1, 1, 6, 6, 15, 15, 20, 1, 1, 7, 7, 21, 21, 35, 31. These all repeat, and it's and you don't have to like use my formulas once you get to halfway. That's why I said earlier we only have to get to halfway, because then all of the coefficients, they just repeat, they reflect basically, and that's what makes it easy. So once we get to the power of 20, all we really have to do is start going backwards. So the next term has to be 15, 6, and then 1. And all we have to do is keep following the pattern for here. We're going to minus 1 plus 1 until we get back to 1. So, and the thing is, you guys might be wondering, when is it that we actually start? No, when is it that we know that we have to go back? When is it that we know we reached the halfway point and go back? Well, there's this thing. So when it's something to the power x plus y to the power of, let's say, an even number, let's say 4, okay, we know that there's n plus 4, so there's n plus 1 term, which is 4 plus 1, so we know that we have 5 terms, 1, 2, 3, 4, 5, and with 5, it's an odd number, so 5 is odd, so 5 is odd, and with odd number, there's always going to be a term in the middle, okay? So with odd number, we're gonna minus 1 times 1/2 plus 1. Or you get plus 1 times 1/2 and then minus 1. So with this, x plus 4, there are going to be 5 terms. So basically, we're going to, with 5 terms, let's do the minus 1. We're gonna minus 1, which is 4, and then we're gonna divide it by 2, which is 2, and we're gonna plus 1, which is 3. So once you get to a third term, that's where you start going backwards. But wait, that's only for odd number. What about even number? So what if it's x plus y to the third? I know this is not an even number, but remember, we're gonna plus 1 to it. We're gonna plus 1 to it because it's actually 3 plus 1 terms. What if there's an even number of terms? 1, 2, 3, 4. Doesn't these two repeat? Exactly, it does. So basically, we're gonna get, it's 3 plus 1, 4. So we're just gonna divide by 2, which is 2 terms. And instead of just going back, so it's like 1, 3, 1, we're gonna go 1, 3, and I'm gonna reflect the whole thing back, which is 3, 1. This one we only end with odd numbers, so we don't reflect the number in between. We leave this one here and want to reflect 2 on 2 sides. So basically with this, what I'm trying to say is, this is 6. 6 plus 1 is 7. It's an odd number. So once we get to here, we just leave it. And we're going to go to 15. 15, 3x squared 2y 4. Plus, then we're going to go 6. And then it's 3x to the power of 1, 2y to the power of 5. And the last term, plus 1. And if there's no more 3x, there's only 2y to the power of 6. So if we were to simplify it, it is 1 times 3 to the power of 6, which I cannot do by head. I'm going to use a calculator. I mean, I hope that your teacher lets you use calculator for questions like these. So it is 3 times 3 times 3 times 3 times 3 times, which is 729 x 6. Okay, so that's the first term plus, and then 6 times 3x to the power 5. 3x to the power of 5 is well, 3 times 3 times 30 times 30 times 30. That's 243. Okay, so it's 243 multiplied by 6. So we're gonna multiply by 6. So it's 1,458. And then we're also gonna have to do this 7y to the power of 1. Just so we're gonna have to multiply 7y to it. So it's gonna multiply by 7, which is actually not this number, but 10,206 x to the power of 5, y to the power of 1, x to the power of 5, and a y to the power of 1, just y. Now we're going to keep going. I'm going to do one more term for you guys because it's real late. It's actually 4 a.m. outside. I don't know if you guys can see, but it's actually 4 a.m. outside. So I'm just going to do this last one with you guys because it's getting real late. And the recording is like 40 minutes long. So we're going to go one more. Okay, so let's do this one. 3 to the power of 4. Okay, that's 81 plus, so it's 81, and then 7 to the power of, that's 7 squared is 49. So 81 multiplied by 40. Let me just do clear. 81 multiplied by 49. 3,969. And now you have to multiply 15 to it times 15. Okay, so that's 59535, and we're going to follow the pattern. X to the power 4 and a y squared. And it's going to go dot, dot, dot. And we're just going to go all the way till you reach the last term, 2y to the power 6, which I could do by head, which is 64, y6. But basic y to the power 6. But basically, you get what I'm trying to say. I hope. So that is and I came up with this formula or theorem or whatever you want to call it. I came up with it myself. So I'm actually making this recording so that if somebody else comes up with it, I could say, oh, I came up with it first. Because other than the way I did it, which is multiply, I know there's someone who came up with a way where you can divide everything, which is basically the reciprocal of what I did. But I feel like mine is faster because multiplication is always faster than division. That's why I believe. I don't know if it's just me, but I really hope this video helped you guys with binomial theorem. I came up with it myself. So if you have if you have any questions, you can leave it in the comment, and I'll try and help you guys out. I mean, I'm not a math genius. I'm not really that good at math. I'm just in calculus right now, so I mean, I'm not that good. I'm just taking normal classes. But I just thought it's a really cool trick that I found out, and I wanna share it with you guys because I'm past the age of doing binomials. Because in calculus, you don't really work with things like these anymore. It's much harder, and I mean, even though I figure out this trick, it won't help me anymore because I'm past that age. I won't be